Hi guys, and welcome back on my channel. In this video I'm going to show you how to create this animated sphere in two ways, using the native modifiers of Blender and using the geometry nodes setup. So let's get started. I'm working with the Blender version 4.1.0. First way to create this sphere is using the modifier stack. So to do this we can add with the Shift A mesh Icosphere. We can increase a little bit the scale and apply the scale with the Ctrl A apply scale to have the scale zone to 1, 1 and 1. And first of all we need to separate the edges of all these faces, and to do this we need to add a edge split modifier, and instead of using the edge angle we need to split all the edges, in this case the sharp edges. So to do this we need to go in the edit mode of this Icosphere, press 2 to enter in the edge selection, press A, right button and mark sharp to mark all these edges as sharp, press tab to exit from the edit mode, and next we need to displace a little bit each of these face to make a gap between them. And to do this we can add a displace modifier like this. And remember, if you don't set the edges as sharp, you cannot see this difference between this edge split and the displace. Next we are going to use a new texture, clicking the new button and entering inside the texture properties, and we can select the clouds effect using these parameters, increasing a little bit the size, so 0.4 for example, and going in the modifier, increasing a little bit the strength of this displacement using the global coordinate system, and decreasing the mid level to have these effects, so to pull the faces away a little bit to have more gap between the faces. Next step, we need to bevel the vertices of this Icosphere, and to do this we can add another modifier like the bevel, selecting the vertices to have this effect here, increasing the number of segments to 9 for example. Next we can solidify and make a hard shape, adding the solidify modifier. We can set a thickness of 0.083 in my case, leaving the offset to -1. And as you can see, if I increase the thickness, this is the effect, so I'm going inside the mesh thanks to this offset value. Next we can add another bevel after the solidify to bevel all these edges here and to make a smooth effect on this shape, adding the bevel another time, leaving the edges, increasing to 12 the segments of this smoothness, leaving the other parameters as is. And finally we can add an auto smooth by angle modifier, leaving the angle to 30 degrees. Now to make an animation of this sphere I can for example use a rotation of only one axis, like the Y for example. I can go to the frame 1 and on the rotation press I. Remember that in the new version of Blender you could probably have the new shortcut instead of I to enable the auto insert of the keyframe of your attributes. Next we can go to the frame 100, set -50 degrees and press I again. So the problem here is this: if we leave the original coordinate system of the Displace when you insert this modifier, you can see this effect. So we can rotate the object, but the displacement is the same from the first to the last frame of the animation. So first of all we need to go in the animation tab, select the object, select all this frame and press V and select the vector type, because if I press Ctrl and Tab to see the graph editor, you can see the difference between the previous handle type of this keyframe, as you can see, but I want a linear animation from the first to the last frame. So to do this we need to press A to select all the keyframes, V to select the handle type, and select vector to have a linear movement. So in this way, if I go on the first frame and press play, I can have the linear animation. But we have the same problem as mentioned before. So we need to modify the texture of the displacement of this modifier while the animation. So to do this, we can easily select not the local but the global coordinate system of the object. And because we are rotating the axis of the object related to the global coordinate system, we have a changing of each of these points of the shape inside the global coordinate system. So in this way, the texture doesn't follow the rotation of the mesh itself, but remains static, okay, fixed on the global origin point and the global coordinate system. And if I move the object, I move all the elements, all the edges and the vertices in the space, and for this reason I have a different texture in the space. So each point of this mesh will have a different texture value, and for this a different effect of the displacement modifier on each point of this shape. So to see better the animation, I will disable for a moment this bevel to have a smoothed animation. Now we can decrease to 100 the entire animation, and in this way we can loop pressing play from the first to the last, and this is the final mesh. Now let's do the same using the geometry nodes setup. I will make this almost with the geometry setup because the last bevel it's difficult to do. Maybe I will create a new tutorial to create this bevel on a shape like this, but for now we are going to create the same setup without the last bevel with geometry nodes. So first of all, we can create a new mesh with the Shift A mesh plane. We can move it a little bit on the Y like this. Go to plus, general, geometry nodes and click the new button. So first of all, we need an Icosphere, and we can insert, instead of using the group node, we can use the Icosphere. Let's increase the subdivision to 3, and because on our object we have without the modifiers a dimension and size of 5.8, we need to go here in the Icosphere radius and set 5.8 divided by 2, because this is the radius, but this is the entire size of the bounding box of this Icosphere previously made. So now on these we can add the first modifiers, so the split edge, we can insert these and the first modifier is done. The next is the displacement, so we can displace these, and to displace these mesh we can use the set position, adding these, adding a noise texture like this to have a similar displacement of the texture selected in this modifier of this sphere. I'm going to use the 4D because I want to change the texture while the animation. To do this, I'm going to link this W to the scene time seconds field and setting the scale of 2, detail 2, 0 roughness and stop. After this, I need to link the factor inside a multiply value because I want to amplify the result, and this multiplication is the same as the strength value that you can see in this displacement socket. So for this reason I need to multiply by the same value. Then the concept of the displacement, as you can see, the movement of these points has to be out, in the direction out from these objects. So we can use the normal of each face to move each point outside using this texture. And to do this, we can use the normal field of each point and scale this normal by the value of this noise texture. Next, we can link this to the offset, and voila, the same result of this sphere if I enable the displacement. We can select all these nodes, Ctrl J F2, Displace. We need to add the bevel of the vertices, but here we have a very serious problem, and we have the trick to fix this. Because there isn't a way to use a node, a bevel node inside the Blender workflow, we need to convert this mesh in a set of curves, use the fillet curve node to fill the control points of these curves, and then convert these curves again in a mesh. But there is a problem. If I use a mesh to curve here, as you can see, I lost all the faces because we have no mesh. But the problem is not this. So after this node, we need to use the fillet curve that has a very big radius. So we need to decrease to have a similar result of this sphere if I enable this bevel on the vertices. And so, for example, we can select poly, account equal to the values of the modifier of the first object, so 9 segments. And instead of using an amount of 0.1, we can select our mesh and here set 9. And as you can see, the fillet value is too much, this radius. So we can set 0.05 to have a similar effect on our curves. Now, the problem is in this moment, because if I use a fill curve, this is the result, okay? Blender moves all the points on the X and Y plane to be able to create the faces on this mesh. And if I set the angle, because I don't want to triangulate the faces, but I want for all the face a single face, okay? The problem remains. So how can I fix this? I need 2 steps. One, because all the faces are moved from the previous position, the correct position, the right position, to this plane, I need to reset the position of each point where in the old position before the fill curve. So to do this, we can add a simple index node, selecting the vector of what? Selecting the vector of all our points for each index, it's obvious, and linking the value to the position of the set position. Okay, now the position is correct of each point, but we have a problem. So the number of the index set to the control points before and after this fill curve is changed. Why? Because I'm not using a group ID to separate the creation of the fill curve. So to prove you this effect, I'm going to mute this fill curve for a moment. This is an example of what the fill curve does. So as you can see, we have a simple workflow with a star curve, a circle curve joined together, and then a fill curve. As you can see, the system is trying to create an angle, but executing a Boolean operation between the curves, and as you can see, we have a hole made by this curve circle. And if I take this and transform the geometry to shift a little bit this curve before going in this join geometry, look what happens here. Okay, as you can see, we are making a different mesh, but we don't want this. We want to separate the star curve as one piece of the mesh. We want to use to create the own face, and we want to leave this circle curve alone at the same time to create the own face, so the own piece of the mesh. So to do this in the same way with our geometry here, we need to go inside this workflow. I mute for a moment the set position. I unmute this fill curve to see the repositioning of all these curves on this plane by X and Y. And as you can see, we have the same behavior of the star and the circle, and this is wrong. We want to separate this curve to create the own fill, to execute the fill curve for each curve without affecting all the others. And to do this, we can use the index, that in this case is automatically in the domain of the curve, and linking these, we can have this result. If I press Shift and Z to see through the object, as you can see, now we have one face for each curve. The distortion is normal because we have displaced each of these triangles in the space, but I assure you that we have separated face created inside this set of curves. And now we can unmute the set position to remove to the original position each of these triangles, because the system knows the original position of each point thanks to this sample index node. And with this little trick, so the using of the index and the set position, you can create from curves the faces while converting curves to a mesh. Even the position of each control points of your curves is not on the plane by the X and Y axis. We can select all these nodes, press Ctrl J, F2, bevel vertices. Next, we have another issue. If I enable with my shortcut Q to see the quick favorites, the face orientation, as you can see here from the viewport overlays, face orientation, it's the same command. We have a problem of the normals of our new faces caused by this fill curve node. So to fix this problem, we can think this. In this case, we can think about the origin point of this object and ask us, where are all these faces pointing in this moment? So as you can see, all these blue faces are pointing outwards from the origin of this mesh, whereas these faces are pointing inwards, this face. So to flip only these, we can get the normal of each face, we can get the vector of the position of each face, and for the blue configuration is this, the result, and for the red faces the result is the opposite, so the normal is this, but the vector of the position is always in this direction. And with these two configurations we can ask if these two vectors are parallel. So to calculate these we can use the dot product, that is the multiplication between the length of this vector, the length of this vector, and the cosine of the alpha between these two vectors. In this case, the alpha between these two vectors is 0, so we can have a sort of a range of the normal because we have a displacement that changes the normal of these faces while the animation. So we can use this plane of range to have all these degrees in the dot product to mask the faces on which we don't want to change the normal, so we don't want to flip the face. So as you can see, with these two vectors we have 0 degrees and the cosine of 0 is 1. Okay, in this case we have 1. And remember to normalize this vector before doing the dot product, because I remember you the dot product is a scalar number, so it's not a vector but is a number. In this case we have a little alpha, so instead of 1 we have a decreasing value up to 0 in this case and 0 in this case. So in this way we can understand that if we have values of the dot product result greater or equal 0, we don't want to flip. If we have values of the dot product less than 0, so as you can see, for example, for this face in which we have the normal in the opposite direction, and in this case we have exactly -1, we want to flip the normal. So to do this we can take the normal of each face, the position of each face, we can normalize the length of the position because the normal has always a length of 1, but the position no, because I can have faces distributed in every point of the space. And after this we can calculate the dot product between these two values, and if this result is less than 0, we can use this result to flip the face. And if I link these and link this mask, as you can see, I always have all these faces blue going and pointing outwards from the center of this object. Remember, in this case the position, so the origin point and the calculation of the vectors of each faces starts from this origin point of the object. So don't be confused if I take these and move these in the 3D space. I'm not considering the origin point from the global origin point, but the center of the object, so the origin point of the object itself. Okay. I forgot to test the animation of this displacement. So if I press play, as you can see, we have a similar animation between the old style and the new style. Now I can press pause Q to disable the face orientation. We can select all these nodes, Ctrl J, F2, flip faces. Next we can add the Solidify modifier like this. To solidify we can use the extrude mesh, it's obvious, and in this case we need to use the individual, it's obvious, we need to use the normal as the vector for the offset, but we need to offset to the opposite direction by what? By the same value of the Solidify in the mesh version, so 0.083, but in the opposite direction, as you can see from this attribute. So we can go here and set minus 0.083 like this. But we have a problem. Using this technique, we always lose the original face using the extrude mesh. It's the default behavior of this node. So to include the source faces, we can join them together to have these. But remember, if I re-enable the face orientation, you can see we have the correct normals of the face, but the opposite normal of the new faces created. So we need to flip the faces of this new extruded part. So to do this, we need to go here and add a flip face on this extrude to have all these faces blue. And because we extruded a face and added new vertices inside this mesh, we need to add a merge by distance to have less vertices. Look here, 28,800 vertices. But if I link these merge by distance inside the group node, we have this new number. We can select all these nodes, Ctrl J, F2, Solidify effect. We can add a set smooth node on the faces like this. We can add a set material that we are going to add as the last step. And I'm sorry, but about the last bevel modifier, we need to add as a new modifier because I haven't created a node to do this yet. So we can add a bevel like this, 12 segments with a limitation of the angle like this. And now we have the same result of these two meshes. Q, face orientation. We can enable the bevel on the mesh, go in the layout, and as you can see, we have two similar meshes. To see the animation, I disable for a moment the bevel of this object and the bevel of the geometry nodes system like this. I go for a moment inside this to mute the set smooth, go in the layout and press play. And as you can see, we have the same effect on these two shapes. Now let's create the shading. I'm not going in the detail of this shader, but I'm going to create a new material. I want to use the change of the hue, saturation and value from a range of colors, starting from an RGB color. I link here, and now I want to mix the hue value using the normal of each face. So changing the normal direction of this face, I want to change the hue of its color. So I can add a geometry node like this, link the normal in an add mathematical operation. I will add 1, multiply this value by 10.6, make a truncated modulo by 1, because I want to use these output values between 0 and 1, where inside a map range, linking these to the hue to change these colors, and tweaking this ramp to not going away too much from this standard color. So I don't want to use a range too big to change the hue. So I will set these values to these values here. Perfect. I want a metallic object with a little roughness. Save the project. Take this object, and in the geometry nodes I select this material, going in the layout and selecting these. Now I can go to the geometry nodes. I can re-enable the set shade smooth and enable the bevel in the original mesh, go to the layout, and this is the final result of both of these meshes. I delete this geometry example, I delete the annotation, save the project. And why this tutorial? Because I want to suggest you to always meditate well when you are modeling something. If you have a time to spend to make your model using a destructive way, so using the tools inside the Blender like the extrude, bevel and whatever tools you need, or use the modifier stack that sometimes can be very difficult to tweak to reach your goal, or use the technique of the geometry nodes that in some context is more powerful than the native modifiers, but can be more difficult to use and can take more time than the native modifiers. Thank you guys for watching this video. I hope you learned something new, above all the fill curve node on curves distributed in the space to get faces for a final mesh. You can download always this project from my Gumroad page. If you like it, please check a like, subscribe to my channel. Don't forget to check the bell icon to get all the notifications of my videos, and see you to the next tutorial. Bye!